M2 is 0.06. M2 0.06 kilogram, and then the U2 is 3. U2, you are told this is 3 meter per second. Okay. Now the two masses has an elastic head-on collision. So the kind of collision they were involved in is an elastic collision. They had so this is an elastic, perfectly elastic head-on, head-to-head collision. So another important thing you must understand, you must find out the kind of collision. Is it elastic or inelastic? So what is the velocity of each ball after the collision if the two balls are moving in the same direction? So Saida, mute yourself. You are looking for the final velocities. You are looking for the final velocities if the two masses are moving in the same direction, initially, because for the final direction of the bodies, you can only get that after you found V1 and V2. And if they are moving in opposite directions. So two in one question. Okay, so the first thing you have to do is that since this is an elastic collision, write an equation for in an elastic collision. The features are that 1, momentum is conserved, and 2, kinetic energy is conserved. So there is a conservation of these two. Class, are you with me? Are you there?
Yes.
Okay, so let's write equation
Yes.
for the conservation of momentum. M1 times U1. First, they are moving in the same direction, so plus M2 U2 must be equal to M1 V1 plus M2 V2. Okay, let's put in our values. M1 is 0.04, so 0.04 times U1 is 5 plus 0.06 times U1, which is 3, is equal to 0.04 times V1. V1 you don't know, plus 0.06 times V2. V1 and V2 is what you are looking for. And this is the equation for conservation of momentum. Write the equation for conservation of kinetic energy. Okay. Half mv, but if you recall, we multiplied through by 2 and had m1 times u1 squared plus m2 times u2 squared plus is equal to m1 times v1 squared plus m2 times v2 squared. So let's substitute our values. 0.04 times 5 squared plus 0.06 times 3 squared is equal to 0.04 times V1 squared plus 0.06 times V2 squared. So you play around. Is this 25? Okay, 25, 0.04 times 25 plus 0.06 times 9 is equal to 0.04 V1 squared plus 0.06 V2 squared. And this is equal to 0.2. This is equal to 0.18 to be equal to all this. Therefore, the final one becomes 0.38 is equal to 0.04 V1 squared plus 0.06 V2 squared. So you have equation 1. If we simplify this, let's simplify the equation for conservation of momentum. Okay, this is 0.2 plus
Mr.
this
Adrian,
is hello.
please, there's 0.04 times 25. The answer is 1. So why is it 0.2?
Hey, oh, okay, you are right. You are right. Watch me closely. So this is 1. Okay, 100 divided by 100 divided by 100. So 1, and I'm sure that this is correct. Hold on, this is also
No.
6 times 9 over 100. That's 0.54. 0.54. So when you add this, you have 1.54. I think I was looking at this one. Okay. Now this is 0.2 plus 0.18. 0.18. Okay, and this rather will give us 0.38. So 0.38 is equal to 0.04 V1 plus 0.06 V2. So class, this is actually what, if you are solving, this is what you solve simultaneously. You solve a linear equation and then a quadratic equation simultaneously. Okay. Maybe we should go through it. Let's go through it to see what we can get before we use the coefficient of restitution to solve. So I want here in solving this, you have to make one of the variables, okay, the subject, and we will use equation 2 and not equation 1 because this is linear, this is quadratic. It is easier substituting this into this and not the other way around. Class, are you okay? Are we fine?
Yes, please. Yes.
So let's rather make one of the variables the subject from equation. We can call this 1, 2. So because I want us to make V1 the subject from equation 2. So we'll divide through by 0.04. So when we divide through by 0.04, we have 0.38 divided by 0.04 is equal to 0.04 divided by the same thing, V1 plus 0.06 divided by 0.04 V2. So that V1 will be equal to, please, what is 0.38 divided by 0.04? Give me the answer in 4DP. 0.38 divided by 0.04. Please, let's not waste time.
9.5.
1.5,
9.
1.5,
9. 9. Like 8, 9, 10. 9.
9.5.
5. 5.
Exactly. And then 0.04 divided by 0.03. Is it 1.5?
Yes.
Akosia?
This is 1.5.
1.5
Yes, please.
V2. So when
Yes,
we make
please.
V1 the subject, we have 9.5 minus 1.5 V2. So we've made V1 the subject. We are going to substitute that into equation 1. So in equation 1, wherever we see V1, we are going to put 9.5 minus 1.5 V2. So substitute, let's call this as equation 3. Substitute equation 3 into equation 1. We are teaching muscle substitution, so solving of simultaneous equation substitution method. So 1.5 is equal to 0.04. This is V1 squared. So 9.5 minus 1.5 V2 squared. Then plus 0.06 V2 squared. When you are doing this, you have to watch very well, because when you are not careful, you can easily commit an error. Now, the next thing is that, you see, I'm going to square what is within the brackets. Whatever I get, I multiply by that. But since 0.04 is multiplying, I can eliminate it by dividing through by 0.04. So I'll do that at both sides of the equation. Divide through by 0.04. Okay. In that case, this and this will cancel. So I wouldn't expand and multiply by 0.04. Please, are you okay here with what I've done so far? I divided through by 0.04. Are we okay?
Yes.
Are we okay?
Yes.
All right. Then I'm adjusting the screen. Can I adjust it so we continue? So, Ekweadoma, divide 1.54 by 0.04 for me. What is 1.54 divided by 0.04?
38.5.
So 38.5 is equal to, you see, I've eliminated this. So what is left is whatever I have within the brackets, squared, minus 1.5 V2 all squared, plus, appear what is 0.06 divided by 0.04? 0.06 divided by 0.04.
1.5.
So this is plus 1.5 V2 squared. Good. You see, now I can expand this easily. Okay. because that's the only thing left. So let's expand what is within the brackets. Now, if I have A minus B, how do I expand A minus B? Yes, Chrysler, how do I expand A minus B? Chrysler, where are you? Go ahead. Let's not waste time. Expand A minus B all squared.
A minus B all squared
Mhm.
is A squared minus 2AB
Minus
plus
2.
B squared.
Thank you. So this is what we apply in expanding this. Okay. This is what we apply in expanding this. So we square 9.5. What is 9.5 squared? Yes, quick. 9.5 squared.
90.25.
Take your time.
90.25.
So 90.25. Then what is 9.5 times 1.5? 9.5 times 1.5. Then what multiply whatever you get by 2. So 9.5 times 1.5 first. 9.5 times 1.5. Let's hurry up. Hurry up.
28.5.
Okay, multiply whatever that gives you by the power 2.
28.5.
So 98.5 plus 1.5 squared. This is time V2. 1.5 squared.
2.25.
So plus 2.25 V2 squared plus this 1.5 V2 squared. So that's the expansion. So let's add like terms. Quickly, we can add this to this. 38.5 minus 90.25. Okay. Minus is equal to minus. Let's bring this first. 1.25 plus 1.5. 1.25 plus 1.5. Eh?
2.75.
Is it 3? That is 3.75.
2.
2.75.
Open your eyes. So you have 2.25 plus 1.50.
3.7.
So you have 3.75 V2 squared. Then the minus 98.5 V2. When you are doing this, please open your eyes because the listing, you get it wrong. 38.5 minus 90.25. 38.5 minus 90.25. Ekweadoma and Co. Please hurry up. Hey,
Minus
No.
5, 1.75.
minus what? Minus what?
minus 51.75.
51.7.
51.7.
75.
So it's minus, but because I want to equate everything
Mr.
to
Dear,
zero. Hello,
please, there is a mistake.
where?
The 2 times 9.5 times minus 1.5 is 28.5, not 98.
9.5 times 1.5 times 2.
Yes, please.
Is that is what?
28.5.
28.5. That's why I said when you are doing this thing, watch carefully and let it be double checked before. 9.5 times 1.5 times 2.
Mr. Dear,
Hello.
Mr. Dear, please. The why is it 3.38.5? I thought the equation we used there we got 1.5 or so. How did it become 38.5 here?
Look at it here. I've even mixed out where we substituted here, and then 1.54 divided by 1.54 divided by 0.04. Do that for me. Let's see what that will give you. 1.54 divided by 0.04. Erase, I'm waiting for you.
Okay.
Is that the correct answer?
Sir, please, I'm doing it. Yes, that's correct.
So that's the reason we had 38 points. Now Charlotte is drawing our attention to what we had here. You square this 90.25, which is 9.5 squared. But let's confirm 9.5 times 1.5 times 2. Let me see what that actually gives us. 9.5 times 1.5 times 2.
28.5.
You see what I've always been telling you. Let's all get involved in this thing. We want to quickly finish this and move on. Look at, because of this, we have to come back. Meanwhile, we are all here to do this and make sure it is right. And if she had not drawn our attention, we would have had everything we are doing would be cost 90. So please do not sit on the fence. Get involved in what we are doing. I always talk about this thing. So look, I've even cleared whatever we have. So 3.75 V2 minus 28.5 V2. Okay. Now here I want to equate everything to 0. So that is why earlier I was transferring everything, equating this to 0, knowing that this will give me negative. When you cross it, it will be positive. So I have 3.75. Okay, let me bring this first. I'm coming. Where is the V2? Okay, so I have 28. Okay, 3.75 V2 squared minus 28.5 V2. Now, when you subtract 90 from this, you get negative. So when it crosses, it's plus. And that is plus what? 38.5 minus 90.5. What did it give it? What did we get for 38.5 minus 90.25?
51.75.
That's 51. We have 51.
Yes, please. 0.75.
Good. So this is the quadratic equation we have. Now we compare this to almighty quadratic equation formula. Ax squared plus bx. When we compare, a is equal to 3.75 because x is v2. Then b is equal to negative 28.5. And c is equal to 51.75. This is how to use the almighty quadratic equation formula. The formula is x is equal to negative b plus or minus root of b squared minus 4ac over 2a. Okay, our x is v2. So v2 is equal to, let's substitute these values we had for the constant. B is negative, but this is negative of B, so plus 28.5 plus or minus square root of 28.5 squared. I eliminated the minus because when you square minus equal to positive. Minus 4 times A, 3.75. C is 51.75. All divided by 2 times A. Simplify what is within the bracket for me. Just punch it in your calculator straight. Square root of 28.5 squared minus 4 blah 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 this. Punch, input that into the calculator. Please, I want 2 people to do it so we can confirm our answer. Square root of, then input 28.5 into bracket and square minus 4, then put them into bracket. It will give you the final answer. It must be done by 2 people so we have a common answer. Let's not waste time, please.
6.
So 6 divided by the denominator. Two times 3.75.
7.5.
So we'll have 2 answers for V2. One will be 28.6 plus 6 over 7.5 and 28.6 minus 6 over 7.5. Give me the first one. What is the first answer? What is the first answer? Somebody should work on the second answer. What's the first answer?
$4.613.
So 4.613. 613 meter per second. And what's the second answer?
Three.
Pardon?
3.
So 3 meter per second. So these are the two possible answers for V2. Once we have V2, we can easily use this equation. Look at equation 3. V1 is equal to 9.5 minus 1.5 times
Yeah.
V2. Hello?
Please, I made a mistake. It's 3.01.
3.01. Okay. So I think it's still within. So because V1 is equal to 9.5 minus 1.5 V2, we can easily use this to find the two possible answers for V1. So what's the first answer? When you substitute the first value, 4.613, and then somebody should also substitute the second one to give me the second value for V1. Let's hurry up. Let's hurry up. V1.
2.580.
2.580 and
4.985.
4.985. So using the two equations, these are the possible values for V2 and V1. Now, you see, this is so lengthy. The little mistake, you are getting this wrong. And so we can use a very short method to get the same thing. Please take note of the answers we had for V1 and V2. We are going to use the formula for the coefficient of restitution. That formula we derived to do the same thing. Solve it easily. Can I clean the board? Do I clean the board?
Yes, please.
To get this or to use this, your mathematics must be so strong, because the little mistake you do, you drop flat at your back. Let's use relative velocity of approach is equal to the relative velocity of separation, out of which we got the coefficient of restitution. This is U1 minus U2. This is equal to V2 minus V1. And please, look at the question we just solved. We even simply looked at when they were moving, the two bodies are moving in the same direction. We never even looked at when they are moving oppositely. So you can imagine how lengthy if you are using that approach. Okay. How lengthy will be the time if you are to use this approach? But let's look at this one. U1 is 5. U2 is 3. And this formula was derived using when the two masses are moving in the same direction. When we finish, we'll look at how to apply when they are moving oppositely. V2 minus V1. So V2 is equal to, this is 2 plus V1. So substitute this into any of the equation, any of the conservatory equations. Who is now coming? Moto. Moto. We are closing on Moto. So substitute this into any of the conservatory equations. Either the conservation of momentum